4.1.2, we have an algebraic or an algebraic equation with algebraic fractions involved. So on our left-hand side, we have two fractions being subtracted. So that's 5 plus x over 2x minus 4 minus x over 6x. Now, this is simply the difference of two fractions that have different denominators. And of course, on the right-hand side, there's also the fraction with its own denominator. And we know that before we can do anything to these two fractions to simplify them, we need to find an LCM in order for us to move forward. In other words, I need the same denominator, an LCM, a lowest common denominator that will accommodate all of these different denominators. These are different denominators, and in order for me to proceed with the solution of this equation, I need to find an LCM. Now, I'm going to look at my denominators in terms of the numbers. So these are called coefficients, of course, but if we just look at what would accommodate these three numbers, 2, 6, and 4, its lowest common multiple. In other words, if I had to count in 2s, and if I had to count in 6s, if I had to count in 4s, what is the first common number that they will reach together? And that, of course, would be 12. So if we write here our LCM would include 12, and then we need to look at the variables involved as well. So there's a variable of x over here, and the highest power of the x's involved here is 1. So that means I need an x in my LCM that can accommodate the most amount of x's in all of these denominators. And of course, this guy does not even have an x, and both these fractions have x to the power of 1. So I simply will include an x in my LCM as well. So because this is an equation, I can simply, remember, I do not want to be working with the denominators in my equation. I would effectively like to get rid of them. So, and I'm not going to do it like that, of course. So I'm going to, because it's an equation, I can simply take my LCM and I can multiply every term across this equation with the LCM. And in so doing, I would then be able to get rid of that LCM, or those different denominators rather, because these denominators would then be dividing into the LCM. So let's see what that looks like. So I'll have 5 plus x over 2x, and I'm going to multiply that with 12x over 1. Not 12x over 12x, just 12x over 1, minus 4 minus x over 6x, multiplied also with 12x over 1, and that is equal to the 7 over 4, and that will also be multiplied by 12x over 1. So now I can, my 2x can divide into the 12x, so 12x divided by 2x will be equal to 6, and that will then result in an answer of 6 in the numerator multiplied with the 5 plus x. Minus my 6x will divide into the 12x to give me 2. Because remember, the x's will be effectively cancelling, so you will just be dividing the numbers in those cases. So that will be 2, 4 minus x. And note that we kept the sign, the negative sign that was there, nothing happened to that, so that stays there. My 6x divided into the 12x, and out popped the 2, keeping the negative sign that was in front of that. And of course, making sure that I include brackets now, because my answer to these divisions is standing outside of what was there in the first place. So 6 multiplied by the bracket, and here we've got negative 2 multiplied by this bracket, is equal to, here I'm going to divide my 4, which does not have an x now, into 12x. So 12 over 4 is 3, but remember the x will be part of my solution because there's no x here to cancel out with that x. So my answer for that division will include the x, so that's 3x, and it would be times the 7. I don't really need to put the 7 into brackets because it's just a constant, just one number. And now I'm going to simplify. So what I've got here now is a linear equation, which is a lot nicer to work with than what we started off with. We do not want to work with those denominators. So we have a straightforward linear equation, and we need to just multiply this out, add up like terms, and get a simplified answer. So here I've got 6 times 5 is 30. That, of course, was 6 multiplied into the bracket, and then 6 multiplied into the bracket again to give me 6x. This is where many of us make mistakes. We multiply the 2 into the bracket to get 8, forgetting that it is negative 2 multiplied into the bracket. So your signs there will be affected, which will ultimately affect your final answer. So this will then be negative 8, which is the negative 2 being multiplied into the bracket, and that would be negative 2 multiplied by negative x to give us positive 2x, and that's equal to, this is 3x times 7, which is just 21x. So we're going to reshuffle. Remember, this is a linear equation, so we're just going to shuffle everything around, make sure our unknowns are on one side and our numbers or constants are on the other side. Conventionally, we would want our unknown numbers or unknown terms to be on the left and the numbers on the right. So I have here, I'll just simplify this on the left first. So we've got 30 minus 8, which is 22. And we've got 6x plus 2x gives us 8x. And that is all equal to 21x. Then you can, here I like to keep things positive as far as possible. So instead of bringing the 21 over to the left hand side, I will just subtract 8x from 21x on the right hand side. So 21 minus 8 is 13. So that will be 13x, and that is equal to 22 on my left hand side, and then that means x will be equal to 22 over 13. Okay, so we'll look now at an alternative way of dealing with 4.1.2, and we are still going to use the method of an LCM, but just slightly different from what we've done here. What we've done in our previous example was to find the LCM and then multiply all the way through with it, so that we could end up with a linear equation, and then we of course went ahead and solved for x. In this approach, we are going to look at each fraction individually, and we are still going to choose the LCM, which is of course 12x. That did not change. It is still the same LCM. It's the same problem here. So what we will do instead after this, instead of multiplying with 12x over 1 all the way through, we are going to take the first fraction and say, okay, in order for me to get from 2x to 12x, what must I multiply 2x by? And that of course is 6. If I multiply 2x with 6, I get 12x, but that means I need to multiply both the numerator and denominator with this number. So I will then multiply that with 6 over 6. Then I'll take the second fraction and do the same thing, 4 minus x over 6x. What must I do to 6x, or what must 6x be multiplied with to get to 12x? And that of course would be 2. So I'm going to do that on the top and the bottom. And then on the right hand side, I've got 7 over 4. So what must I multiply 4 with to get to 12x? And that of course would be 3x. So I'll multiply top and bottom with 3x. If I simplify this, I will end up with, remember, if I multiply the 6 with what's in the numerator is a binomial. So I need to multiply the 6 with the binomial, which means the 6 will be multiplied with the binomial in a bracket, so that I make sure I multiply the 6 with everything that's in the bracket. So I'm going to then say 6, I'll write the 6 on the left hand side just for convenience sake. So that will be 6 plus 5x, 6 times 5 plus x over, and 2x times 6 is 12x, minus, that will be 2 multiplied by 4 minus x in brackets over 12x again. And here I've got 7 times 3x is 21x over 12x. So now I've ensured that coming from here, where I had 3 different denominators, I have now the same denominator all the way through. And then I'm just going to multiply through with 12x anyway. But this was just a different way of getting there. So I'm going to multiply, let's just maybe write here, multiply by 12x. So now I'm going to have, if I multiply the first fraction with 12x, that will just divide into 1. So I'll end up with 6, 5 plus x, minus, and if I multiply the second fraction with 12x, the 12x's will divide into 1. So I'll end up with 2, 4 minus x. And if I multiply the fraction on the other side of the equation, or equal sign, I will just end up with 21x, which is basically what we had over here in that step. So, well, basically here, after we multiplied out. So now I will end up doing the same thing, multiply into the bracket, so that will be 30 plus 6x minus 8 plus 2x is equal to 21x. And then I have the exact same thing as before. I've got 30 minus 8, which is 22. I've got 6x plus 2x, which is 8x, is equal to 21x. So that would be 13x is equal to 22, and x is then equal to 22 over 13. Same answer.